people watching this video. I think it's like Johnny, Josie, and Reese. Page 41, 12 through 44, the evens is the homework assignment for 1-4. Make sure you write that down. This is all angle measures, okay? While I have all of your attention at the beginning of this, 1-4 is halfway through the chapter. Did you know that?
I'm not ready.
Oh my, I'm not ready. Get ready. Get ready, boy. So tomorrow,
Take it today.
but then Friday is going to be crazy because we have all sorts of things going on Friday.
What's going on?
Please.
There's like an intruder drill on Friday, and we walk down to the community center. It's all a big thing. Yeah.
Can we do
Third and first period are switched around evidently or something.
No. Why?
So just heads up, that's going to be a thing on Friday.
Can we do it Monday?
It's all going to be sorts of weird.
Can we do it Monday?
No, I'm not pushing it after Monday.
Whiteboard?
You can use your notes on the mid-chapter quiz. You can use your notes. It's not going to be that bad. You're going to be just fine. And, like, just make sure you have all your notes ready to go. Eli, make sure you have all your notes ready to go. Okay? All right? This is angle measures. All right? So, things you should know, like midpoint distance for the mid-chapter quiz. Angle measures is what we're doing today. This is a really easy section, I feel. Okay? There's some notational things that we have to talk about. So, like, zoom in on this diagram right here real quick. We're going to talk about some notation things. This is an angle. Yes? Woo! Okay. X is called the, you know what that's called? Vertex of the angle. Okay? Vertex of the angle. And then we have sides to the angle. So this is side XY and side XZ. Now, when you're naming the sides of the angle, what did they do special about naming the sides of the angle?
They draw an arrow.
They draw an arrow over top, and what letter comes first?
The point. Vertex.
The vertex is the first letter of the side that you name, right? So it's vertex X, whatever. X, whatever. If that's your vertex, that's the first letter that you say for that side, right? And then you have an arrow going to the right, and it kind of looks exactly the way the side does, right? Like X is the vertex, X is on the dot, and then it goes to the right forever, right? Okay, so that's how that works, okay? So we have that stuff. This angle, we'll start naming angles. This is angle YXZ, or you can name it angle ZXY. Okay, you can name it those ways. Now, what has to be in place in order for you to name it? The X has to be in the middle. The vertex has to be in the middle. Whatever your vertex name is, has to be the middle letter, okay? So you're naming YXZ or ZXY, right? Something of that nature. Now, sometimes they will have the name like simplified even more than that, and rather than naming it with 3 letters, okay, there's like this angle symbol, by the way, I didn't talk about that. It kind of looks like a less than symbol, but you do angle YXZ or angle ZXY. Sometimes they'll name it even easier. So like this would be angle ABD. What's another name for that? DBA, or angle 1. They have it named as angle 1, right? So if they put a little symbol there, a little like number there, you can call that angle 1 and make it a lot easier, right? Okay. So they're just going to ask you questions about this diagram over here. It's maybe hard to see on your paper because it's in black and white, but bear with me. It says name all angles that have B as the vertex. Okay. So B is this guy right here. What's one angle?
One.
Angle 1, right? Angle 1 is that guy. So this angle. And angle 2. Angle 1 and angle 2. We can call them that, right?
Oh.
Hey, there you go. Angle 1, angle 2. Those are the only 2 angles that have B as its vertex, other than this angle over here, which is technically a straight angle, like a straight line angle, but we won't get into that yet. We'll talk about that here in just a minute. Okay, so angle 1 and angle 2 for now, we'll just talk about those as having a vertex of B, okay? It says name the sides of angle 3, okay? Do you see where angle 3 is located? This one right here, okay? So I have this one going this way and this one going this way, okay? So what's this one, the bottom side?
E.
We're going to name it like the side of the angle, right? Sides of angles are named like side XY or side XZ, right? So what would this one look like? CE is this one going this way, and side CB. Okay, now I'm going to argue and say, well, I'm going to call it side CA.
Okay.
Doesn't matter.
Does it matter? No, you can call it side CA if you want to, right? CE and CB or CE and CA, it doesn't matter, okay? So if there's more than one letter along that line, you can be B, is what we said, right? Okay, those two are the two sides with the vertex labeled first. C is the first letter that comes, okay? What is another name for angle GHL? Do you see GHL? GHL.
I don't see it.
GHL. GHL. What's another name for him?
Right.
LHG is another one. Angle LHG. Or you can name him angle.
Right. 90.
No,
6.
that's not his name. That's his value, but that's not his name. What?
7.
Angle? Somebody said it. I think Mackenzie said it. Angle 7.
I said it first.
Did you say it first? I heard Mackenzie say it first. Angle 7. Angle 7. Okay, so any one of those will work, right? All right, now they talk about in the interior of an angle, okay? So if I'm looking at this angle, the interior of the angle is the part, it's like chomping, right? So if I have a point in the interior, it looks like that. It's like where it's chomping. This would be in the exterior, right? Like this point right here would be outside of that angle, okay? The part that it's chomping. All right, so name an angle that is interior of, what was it? DBK? This angle right here. What point is inside of DBK?
E.
3.
E. 3 is not a point. 3 is an angle, right? E. Somebody said this morning, they said angles, or like C. Okay, C is on the side of DBK, right? So C is not in the interior, C is on the line, right? So it has to be point E. Does that make sense? Has to be point E, okay? Moving on. All right, now classifying angles, we're gonna label them as either a right angle, in which case we have a little box in the corner, right? A right angle always has a box in the corner, and that is 90 degrees. An acute angle is smaller than 90 degrees, okay, or less than 90 degrees. And an obtuse angle is greater than 90, right? But they also put the restriction on here that it is less than 180. We're going to talk about that here in a second. So an obtuse angle is greater than 90 but less than 180 degrees, okay? I'm going to add 2 more over here that sometimes they'll talk about. They will talk about a straight angle. Straight angle. Write this off to the side over here. Straight angle. And a straight angle looks like this, where I have like A here, B here, C here, okay? Technically, B is the vertex of that straight angle. It's like I'm looking at this many degrees, right? How many degrees is that? 180, right? A straight angle has 180 degrees. It's like a flat line straight across, okay? We'll have an example like that down below here, okay? And then there's another one that we don't usually talk about in geometry, but I want to bring it to your attention because you'll have it like next year. It's something called a reflex angle. And that is one that is more than 180 degrees. So he will look like maybe like this, but you're looking at this angle, right? You're looking at that angle around, not the acute angle. You're looking at the angle all the way around, okay? And that's going to be more than 180 degrees. This one would be like maybe close to like 300 degrees. All the way around would be 360, right? So this is maybe a little short of that, right? This would be 360. A little less than that would be 300. So that would be something called a reflex angle, okay? A reflex angle. It's like hyperextended, basically. You know, like if you think of that, it's like hyperextended, maybe. Nah, you can't hyperextend that far? That would be really ouchy. That would be really ouchy to hyperextend that far. Anyway,
And what if I want
300 degrees.
750 though?
What?
What if I wanted like 750?
You can. So we start talking about in trig. Really, my calc kids just got done talking about this. It's all like trig stuff. You can have a 750 degree angle, and the way that they relate that is like if you're looking at rotation. So if I'm like asking for my tires to be rotated 750 degrees, that's more than 2 circles around, right? Like you're rotating it more than 2 circles around. Or like the merry-go-round is rotating 900 degrees in one like ride, right? It's going like almost 3 times around, right? You know, whatever. Does that make sense? You can have more than one full cycle around, and that is more than 360 degrees, right? Okay? All right, so let's measure and classify. Example 2, classify each angle as a right, acute, or obtuse. Then we're going to measure. So we're going to classify them first, and then I'll teach you how to use your protractor, all right? So classify each angle as right, acute, obtuse. MJP. MJP is this one right here. It has a little thing in the corner, and that is a right angle. Okay. Now, if it's a right angle, we don't necessarily, we're going to measure it, but we don't necessarily have to measure it. We know that it is exactly 90 degrees, right? Okay. The second one is LJP. P.
Obtuse.
Obtuse. We're going to measure him here in a second and figure out what his measure is. And then the last one is NJP, this little tiny one. He is
Acute.
acute. Okay?
Wait, what?
All right. So what you're going to do is your protractor. I'm going to show you like how to use it. And you may need to. The first one that we're measuring is this like 90-degree one. So what I'm going to have you do, before you start, what I'm going to have you do is extend that line up, extend this line up, and extend this line out, okay? Because we're going to have to be able to see them across our protractor, right? Okay.
How are you supposed to use this thing? That's so
I'll show you.
confusing.
I'll show you, okay? So the protractors that you guys all have, okay?
Or poopy.
You want to make sure, listen to this very carefully, because there's like a little window in your protractor and then there's like a bottom edge. You want to put your bottom edge of your protractor on the bottom side, right? So it looks like this, and then you've got your little window in here too. Okay, you do not want to put this bottom side on this like line, right? You want to line up the bottom of your protractor with the bottom of the line. And you want to also make sure that the little diamond that you have in your protractor is right like over top of J, which is the vertex, yeah? Okay, then you're going to measure M, which is this top one. Is it at 90 degrees?
Oh, dang, I didn't go far enough.
Yes.
90 degrees, okay? What about L, the one that goes over the obtuse one?
75.
What?
75.
No, you're looking at the wrong one. We know it has to be over 90 degrees. So there's a 75 on there, and there's
105.
also a 105. You want to go with the 105 because it's more than 90 degrees. Do you know what 75, hold on, do you know what 75 is measuring? So he's right, there is a 75 measure on there. 75 is measuring from here to here, right? That's 75, okay? So you want to measure from here to here, right? That's 105. So just keep track of whether you're looking at the obtuse side or the acute side, and that will determine which one you go with. So 105.
Another angle.
105 degrees is that one. What about this other one over here?
So 106.
You say 106? Okay, that's fine.
Yeah.
Something close to 105. What's this one over here?
25.
20? 25? This morning they said 22. We'll go 20. I don't care. As long as it's in the ballpark of 20, something like that, right? So 90, 105 is the obtuse one, and 20 is this one, right? Okay, something in the ballpark of that, right? That's how you want to use that protractor, okay?
Yeah,
I thought the
that's
diamond
like
is supposed
20.
to line up with it.
The diamond is supposed to line up with J.
Yeah, like the diamond is supposed to, like the vertex is supposed to be inside the diamond.
No. That's for a different protractor.
Bro, what is wrong with
So
you?
I'll show you. The way that this is set up is that way.
A little bit.
This one right here, and the reason why they don't do that is because you can't see through that protractor, right? So I have, here, you go. You're thinking of this one. Okay?
That's
And
a
that's the case you wanted that to be, because I can see through this one. I can't see through that one, so you just put it on the bottom edge. Okay?
Why don't you just
This
drill
one
a hole
here.
right in the middle, right in the
I don't know.
diamond?
I don't know.
'Cause
Because not only do you have to have it lined up here, but you also have to have it aligned this direction, right?
It's like a little more than half.
So they just make it so that it's on the bottom edge. Make sense? Yes. I have to look up the combination. I don't know what it is. Okay. All right. Let's do the last example. We're going to skip the two on the back side where we have to sketch. So we're not going to do any of these constructions. If you want to me to show you, I can get my compass out and I'll show you how to copy the angle and bisect the
You
angle.
have a compass? That's awesome.
Compass. Yeah.
Where is that?
Not like a history compass. Not like a north, south, east, west compass.
Dang it.
This is a compass. The little thing that draws circles. That's a compass.
That's definitely not a compass.
That's what a compass is.
No.
Yep, that's what a compass is. Anyway, oh, right here. There you go. I can get a compass out and I'll show you how to do that. But anyway, we're going to do this bottom example. And there is a typo on my paper, okay? This one, JKL, cross him out. He says 8x minus 13. His should actually be 16x minus 26. So fix that real quick for me, please, would you?
Yes, ma'am.
That's just reduced. Randomly
What?
Oh.
It is reduced, but I want it to be that instead, okay? All right, so pay attention to the instructions very carefully. We're going to go through step by step, and we'll explain to you what this means. So in the figure, KJ, which is this guy, KJ is the one that goes down, and KM, this guy here, are opposite rays. What does that mean?
Means they're opposite.
They're making a straight line. They are 180 degrees on this side, and 180 degrees on this side. Does that make sense? They are exactly opposite from each other. Okay?
One side is
All right.
180, the other side is that.
Right, exactly. Yep. Okay, so those two are opposite from each other. Great. It says, here is the most important thing. You have to remember what this means. KN. KN is this guy right here, and he is what they call it bisecting. He's a bisector. He bisects JKL. Okay? All right, now, this is what I want you to remember. What does it mean to bisect something?
2.
Split it in two. But how does it split it in two?
Half.
Because technically this guy is splitting this angle, but it's not bisecting.
I don't know. I didn't take
L is.
It only somebody said it already.
45 degrees.
How do people get these?
It splits it in two, but it's exactly in half. Okay?
Joking.
So remember that. This guy is splitting, this line right here is splitting this angle exactly in half. So here's how we note that. Ready? Use this notation. This is what you will see from now on. We have a little bubble right here. You put a little tick mark or a little circle.
Oh, word.
And we put the same size one on the other side. Have you seen like where you have like two tick marks, right?
Congruent.
And two tick marks, that means that they're congruent. Okay, so we'll put one tick mark, and that just notes that those two angles are exactly the same size, okay? All right, now let's continue on. JKL. JKL is this angle right here. JKL. And that is 16x minus 26. Okay, that whole thing, that whole angle is 16x minus 26. Then they give me one of them and they say NKL. NKL, this guy right here is 6x plus 11. And then I'm going to solve some stuff. So this little guy is 6x plus 11, and the whole thing is 16x minus 26. Are those equal to each other?
No.
No, because this small one
Gotta reduce it.
is half of this one, right?
Gotta reduce it.
So that's why you have to
What?
Never mind.
So you gotta do what? What do you want to do?
You like not
Now, one thing we could do, so there's a couple different things that we could do. I'm not going to do Tate's method because we're going to save that for here in a second.
What?
If this is 6x plus 11, this is also 6x plus 11, right? Agreed?
Yeah, I agree.
Yes? Okay, so if I add those two 6x plus 11s together, right? 6x plus 11 plus the other 6x plus 11, that should be equal to
16x.
the 16x minus 26, right? Yeah? True?
True facts.
Okay, so if I do that, what's 6x plus 11 plus 6x plus 11?
12x plus 20.
12x plus 22 equals 16x minus 26. Okay, then what would you like to move?
Subtract.
Let's add the 26 over and then subtract the 12x.
Yep, let's subtract 12x minus 12x. So 4x over here, let's add the 26 over. What's that 22 plus 26?
48.
48. And then we divide by 4. X equals 12. Okay, but that's not what they want. They want to know.
What do they want to know again?
X equals 12. They want to know. Find JKN.
So then you have to plug
JKN.
in 12
So plug 12 in for X. What is 6 times 12? 72. Plus 11. 83 degrees is what that guy is. Okay, now Tate's method. Here's what Tate said. He said, wait a second, 16x minus 26, you can reduce that in half, and that becomes 8x minus 13. So that means each side is 8x minus 13. 8x minus 13. So if that's the case, then we could say this is equal to this, right? Instead of doubling it, we half it, right? And we would get x equals 12, and we would plug back in and get that stuff, right? So 83 degrees is what we want. That's JKN, and there's it, right? That's it.
That's pretty epic.
That's pretty epic. Very good. Okay?
I get that.
That's all I have.
I'm digging it.
You didn't get that. All right. 12 through 44, the evens on page 41. There you go. Remember tomorrow's mid-chapter quiz.
Okay.
Break.
I can't do these.